and sine is 1 over cosecant. Tangent is sine over cosine. Tangent is sine, cosine over sine. I've taught you those before. It's been a while, but I've taught you those before. But some you probably didn't know are you got to try to discover these on a couple of homework problems that had happened in captain. Oh, those are the same thing. But sine squared plus cosine squared is 1, and I'm going to show you the proof of that. Let me see if I have it on my phone. Yes. Your next mastery exam will have these at the top that you guys have memorized. So your next mastery exam will be trig identities that you have to have memorized. These are called Pythagorean identities. I'm going to show you why they're called that. If I have a triangle ABC, what would sine of theta be? B over C, right? So sine squared. What would cosine be? A over C. Everyone agree so far?
Need to write that down.
No, this is a proof why this is true. You didn't believe me that it's true. I'm about to show you. This is B squared over C squared plus A squared over C squared. Correct? Those already have a common denominator, right? So can I add them? Yes. So I get A squared plus B squared. And in a right triangle, what is A squared plus B squared? And what's C squared divided by C squared? So, that is the proof that shows you that sine squared plus cosine squared of theta is 1. Now the others are just rearrangements of that. If I divided everything in this equation by sine of x or sine squared of x, sine squared divided by sine squared is 1. What's cosine squared divided by sine squared? It's on the last slide. Cosine's on top.
Squared.
Cotangent squared. And what would 1 over sine squared be? Cosecant squared, like this. So it's just what you would get if you divided everything by sine squared. If you divided everything by cosine squared, you get that one over there. So these really kind of all come from the same thing there. That's why it's called the Pythagorean identities. Any questions about those? You will need to memorize them, and not only will you need to memorize them in this format, but any arrangement of them. An example of what I mean by that is you will need to know that cosine squared of theta is 1 minus sine squared of theta. You will need to know that that's, what did I do there? I just subtracted the sine squared over. So you will need to memorize these and any arrangement of them.
Did we do the last slide too?
Yes, you will need to know the last slide. Just write it down as a bell here later. I will go back later. You do that. I'll go back.
Sorry.
I'll go back later.
Years old.
Hey. Negative angle identity. These are also called the even and odd identities, and I'll show you why. Sine of a negative angle is the same as negative sine of that angle. So if we look at a sine graph, right, if I look at the sine of pi over 2, that's the same as negative sine of negative pi over 2. In other words, they're opposite signs. An odd function looks like that. So this is why these are called the even odd identities as well as the negative angle identities. Sine is an odd function. So if I get a negative angle, you get a negative value. Cosine, however, if you plug in a negative or a positive angle 64. Subtract 25 over 64 from 1, and what do I get? How did you get that? Subtract 25 from 64, right? Because 1 is 64, 64. So what'd you get? 20, 30, 40, 50. And then square root that? I agree. So sine of theta would be plus or minus the square root of 39 over 64. The square root of 64, I can reduce that a little bit to... Now, I know it's not a plus or minus. There's actually an answer. Why did it give me plus or minus? What do I have to know if it's plus or minus? What quadrant I'm in. And it tells me that. So it gave me plus or minus because it depends on what quadrant I'm in. So it's making sense that at this point we don't know without a quadrant. And since we are in quadrant 4, what is sine in quadrant 4?
Negative.
Negative. So could we have done this with a triangle also?
Yeah.
Would have given us the exact same thing. So this is just another option for a way to solve this same problem. This is a more algebraic option. The other one's more of a geometric approach. So we like to have multiple options in how we solve things. So this one's more algebraic and the first one was more geometric. How would we find tangent? Which equation would we use? Which we have some options. Why is that one a good one to use? Okay. He said tangent squared plus 1 equals secant squared. We have a secant squared, right? We can find secant squared pretty easy because we have cosine and it's just the reciprocal. So tangent squared, is it written 1 plus tangent squared on your notes?
Squared.
Not that it matters, but I'll write it. So secant would be 8/5. So secant squared would be 64/25. Do we agree? Subtract 1, which would be 25/25. What do we get when we subtract 25/25 from 64/25? 39/25. And then we will take the square root, we'll do a plus or minus. Are y'all okay if I go ahead and call that 39 over 5?
Yeah.
And in quadrant 4, what about the one that was subtracted? That's how I got the 39. It's gone. No, you're good. Good question. It is negative. Why is it negative? In quadrant 4, tangent is negative. How do you know that? Those of you who remind us how you know that there's two ways. Okay, opposite over adjacent, right? You can just think about input that quadrant. What would it be? The sign charts or all students take calculus. So we got 3 options. I didn't think about your options. Really, 3 options. In quadrant 1, they're all positive. In quadrant 2, all students take calculus. Okay, secant of negative theta. Well, what does that really equal? Try again. Just secant of theta. Where am I getting this one from? This slide. And by the way, you were supposed to write those down. I don't is not due Monday. Not due Monday. It is due Tuesday. You will actually get a little bit more work on Monday, but Tuesday is going to be a work day. Work day. I won't be here Tuesday at all. So, what? I haven't. I know. And I'm pretty mad about it. It was supposed to be at 3 o'clock in the afternoon. And they didn't tell me.
They can't do that with
Tuesday will be a work day. So I'm going to teach a little more today than I normally would, and teach a little more Monday than I normally would. Tuesday will start working.
Wait, how do you think she could be over?
Okay, so we're going to make Tuesday I'm not going to be here, so we won't worry. So Tuesday you'll be working on I know y'all will. Hopefully, because Monday we'll be able to kind of do this, and then hopefully y'all can kind of help each other. Yeah, she was.
I know. No, what did you do?
Okay, okay, so express tangent of theta in terms of cosine of theta. What this means is if I have a tangent expression, I want to rewrite it where it only has cosine. So instead of tangent, I want cosine. Well, what is the equation that would even relate those two things together? Tan squared plus 1 equals secant squared theta. Why did someone said this? Why did you say that? Okay, there is a cosine involved in here, right? Somewhere. If I rewrite it, this is tangent squared of theta plus 1 equals what?
1 over cosine squared.
Now I want to express tangent as substance. So what that means is I want to get tangent by itself. So subtract 1.
What? What?
And then square root. Can I get rid of the plus and minus this time? No, because I don't know what quadrant we're in, so it just has a plus or minus. So anytime you had cosine, you could find tangent by doing the square root of 1 over cosine minus 1 if you wanted to. You could get a common denominator. Speaking of, everyone listen to this. You can stop here. We're done. But the question was, can it simplify any? If you decided to simplify it, you would have to get a common denominator. Well, you never have to do that. Well, not if this is the question. Are you ever going to have to do this for something else like Monday? Okay. For some other question.
It's weird that specifically.
Well, that's the next thing we're supposed to.
Yeah.
And go usually on Sunday.
Let me quick question. What is 1 minus cosine squared? Look here.
Cosine squared.
Sine squared.
How do you know it's sine squared? Because sine squared plus cosine squared is 1, right? want to do any of this black part for this
Black
question.
cosine squared plus cosine squared. The bottom. Oh, yeah.
Common denominator equals like 1/4 plus 1/4 is. Anyway, pretty interesting. I would simplify it sine over cosine, but remember the black part was not from cross. Some stats that you can simplify. Okay, write secant of theta plus cosecant of theta in terms of sine. We'll do this one on Monday. You have your homework ready. No, it's not.
Oh no, that was our bonus.
What?
Right? Secant of theta plus cosecant of theta in terms of sine and cosine. Okay? This is in terms of sine and cosine, right? And simplify, the only thing we can do to simplify is the common denominator. So what we're doing today is we're kind of just practicing some algebra with trig functions involved. This will head somewhere, I promise. Today we're just yeah, that's trig stuff first. It will eventually get this all. And you get one every night. Hey, I need a common denominator. How do we get a common denominator? Full kiss, I love that. Remember my part. It said simplify, so I'm going to simplify. Thank you.
There you go. Yeah, she did.
What is it? Oh, okay.
Miss Roberts told me that. Me and Paxton told me that same day. You're the girlfriend out and out.
Hey, any questions? Chris, I'm sorry for this video.
Bye, Chris.
Tell us your name.
Alright.
Let's go.
Yeah. Alright. If tangent of theta is 4/3 and theta is in quadrant 3, then find secant of theta. So again, we have two different ways we could do this, but for today I'm going to use algebra. After today, what do you do?
Nothing except for again.
However you want to do it. Now, you will need to use these skills for something else later, but as far as this particular problem, you can do it either way. But it's always good to have both options in your toolbox. To have, or I could do algebraically, or I could do.
And you can copy sharply.
That's right.
Oh, I'm smart.
So which equation do we have that would relate these things together? Yeah, you will have to. In fact, by next Wednesday, which I'll tell you more next week, but by next Wednesday, I want you to have them memorized. You can go ahead and write that down. The ones that we learned today, by next Wednesday, I want you to have them. No, it's going to be math.
Oh, sweet. How would that work?
So like on the left, I'm like tangent squared of theta plus 1. And on the right, I have secant squared.
thought you could match it. That big information. Oh, you can't use that, but it's great.
Is that real?
All right. 16 nights, we agree? Nine nights plus 16 nights is 25 nights, right? We agree? 25 nights. Square root both sides. Does that make sense? Looking at the triangle, and you probably look at the triangle in your head. It's a 3, 4, 5 triangle. So it makes sense that we get 5/3. We are in quadrant 3, so secant in quadrant 3 is negative. Hey, any questions about that? Then you have two options for how to solve that. Okay. These, I hope, when they come up, we really like them. They're really easy. These trig identities show up on ACTs or trig problems. Sometimes they're Pythagorean, a lot of times they're Pythagorean. But yes, they do show up.
On actually.
The last one. Yes. New ACT skills every day. Tangent and negative theta, what is that equal to? Negative tangent of theta, right? Where am I getting that from? The rule. I'm going to memorize that rule. Remember on that page, everything works this way except cosine and secant. And then they just get rid of the negative. So negative 2.6. Any questions about that? Hey, true or false? This is really headed into the big thing we're going to be doing this chapter, which is verifying trig identities. But this is just a true or false question. Somehow I want to know if the left-hand side equals the right-hand side or not.
False.
What is the left-hand side? What is sine squared over cosine squared? Tangent squared? What does tangent squared equal? Secant squared minus 1. So is there any reason to think that tangent squared would equal 1 minus sine squared? Or minus sine, or 1 plus sine squared? No, you could say that sine squared is 1 minus cosine squared, right? But then you just got 2 minus cosine squared, which doesn't get you anywhere. Now, we will get a lot better at this on Monday. We'll practice some of these. For now, if you can't figure it out algebraically, another option is to graph both of them. So on the left, if I were graphing, you could either type it in as tangent. By the way, to graph that, you would have to type tangent of x parentheses squared if you want to graph that. And then 1 plus sine of x parentheses squared. And see if you get the same thing. If you don't, they're not the same graph. This one's going to be a tangent squared graph. That one's going to be more like a sine graph. So not the same. Any questions about that one?